AI systems run on secrets, API keys, tokens, certificates, and encryption keys. If they leak, models, data, and cloud workloads are exposed. In this topic, we'll look at how vaults, KMS, and short-lived credentials help protect them. We've built the identity foundation: who can access what, how they prove it, and where AI agents are constrained. Now we turn to the credentials and secrets that make that access possible, because exposed or overprivileged keys can defeat even strong IAM. Modern AI systems are not one application. They are a chain of connected services: model APIs, vector stores, cloud resources, pipelines, agents, and monitoring tools. Each connection often depends on a secret. If one key leaks, attackers may reach prompts, embeddings, logs, datasets, or cloud privileges. Strong secrets management limits that blast radius with least privilege, rotation, revocation, audit trails, and secure automation, especially when agents can call tools dynamically. These protections usually work in 3 layers. A vault stores and brokers access to secrets like passwords, tokens, and certificates. A KMS manages encryption keys, policies, rotation, and cryptographic operations. An HSM provides a hardened hardware boundary for high-assurance key custody. Together, they control who can use sensitive material and leave evidence through audits. Encryption keys are control points, not just secrets. Custody defines who can create, use, rotate, export, or destroy them. With envelope encryption, the application asks KMS for a data key. The data key encrypts the data locally, then gets wrapped by a key encryption key that never leaves KMS. You store the ciphertext plus the encrypted data key. This protects AI training data, embeddings, prompt logs, model artifacts, and secrets while keeping accountability clear. Secrets should be something workloads borrow, not something they carry. apps, agents, pipelines, and notebooks first prove who they are through IAM, workload identity, policy, and context. The secret broker then returns only the credential needed for that environment, tenant, data class, and privilege level. Access to databases, APIs, storage, and internal systems becomes controlled and traceable, with each retrieval tied to the workload, user, request, and downstream action. Every API key or machine token should be treated as a temporary access contract. When it is issued, record who owns it, what it is for, where it can run, and when it expires. Store it only in a vault or managed secret store. Then monitor usage, rotate it before it becomes stale, and practice revocation. The goal is simple: no orphan credentials, no unknown privileges, and fast shutdown when risk appears. Credential lifecycle depends on 3 connected controls: rotation, monitoring, and revocation. Rotation limits how long a stolen secret remains useful, but it should be automated, risk-based, and mapped to dependencies so services do not break. Dual secret patterns help systems move safely from old to new credentials. Monitoring looks for signals like unusual locations, failed attempts, API spikes, or privilege changes. Revocation must be part of offboarding, decommissioning, and incident response, with clear playbooks for rollback and break glass access. Ephemeral credentials work more like an access badge than a master key. A workload, user, or pipeline receives permission only when it needs it, for a narrow purpose and for a short time. If that token leaks, the attacker's window is small and the access expires quickly. This is especially useful for CI/CD jobs, data processing, model training, and agent tools that should never hold permanent secrets. Workload Identity Federation replaces stored secrets with a trust exchange. A workload, such as a CI job container or AI pipeline, gets an assertion from an identity provider using OIDC, SAML, SPIFE, or a Kubernetes identity. The Cloud Security Token Service checks the trust policy: issuer, audience, subject, repository, branch, namespace, or service account. If the claims match, it returns short-lived credentials for storage, registries, feature stores, or deployment APIs. Just-in-time credentials change the default from standing access to earned access. An agent or pipeline starts with no reusable secret. When a task runs, policy checks the requested action, role, environment, destination, and risk. Low-risk work can receive a short-lived, tightly scoped credential automatically. Higher risk work may require human approval or step-up authentication first. After execution, activity is logged and the credential expires or is revoked, limiting blast radius. Imagine a developer tests an LLM provider key in a notebook, then accidentally commits it. The CI job runs, echoes environment details into logs, and packages artifacts for promotion. That same secret can now travel into containers, training scripts, prompt templates, and agent tool configs. Once an attacker finds it, usage can spike and sensitive data may be exposed. The fix is layered: secret scanning, short-lived credentials, log redaction, and rotation before anything reaches production. Secret protection has to be built into the workflow, not saved for a final audit. Scan early in repositories, notebooks, images, artifacts, and package registries. Keep secrets out of logs with masking, redaction, and structured logging rules. During execution, inject secrets from a vault, sidecar, or workload identity instead of baking them into code or containers. Finally, separate dev, staging, and production with different scopes, owners, and rotation schedules, so one leak cannot spread everywhere. A mature secrets program is managed like any other enterprise security capability. Every secret needs an owner, a system, an environment, a privilege level, and a rotation or expiration policy. Access logs should answer the audit questions: who used it, when, from where, why, and whether it worked. Maturity can then be measured with trends such as hard-coded findings, stale credentials, failed attempts, rotation compliance, and time to revoke. These metrics connect secrets management to IAM, compliance, cloud security, and incident response. Secrets management is a security foundation for enterprise AI. Centralize control with vaults, KMS, and HSMs. Treat API keys and machine tokens as full lifecycle assets. Prefer ephemeral access and workload federation wherever possible. Together, these practices reduce blast radius and prepare you for more secure applications, APIs, data, and AI defenses.